Hey, welcome back to Factoring Trinomials. Here's your quick review. Remember product sum so we can split that middle term, because once we have four terms, we can break it into two binomials, and then we factor, and then we factor, and then we factor again, right? So it's all about the factoring process, and so you want to be pro at that. Let's look at two more examples. 9p squared minus 24p plus 12. Okay, so the first thing is always going to be create the product sum puzzle. So we multiply our two ends, 9 times 12, we get 108, and the middle term is going to be our sum, right? So then right here, woo, those are big numbers. Guys, use the calculator if you need to find what two numbers multiply to 108. But add to negative 24. This is one I would definitely use a calculator on, right, to kind of knock this out fast, because there's probably a whole lot. As you go through a positive product, negative sum, so both of them have to be negative. Okay, and eventually you're going to see that it's negative 18 and negative 6. Okay, so negative 18 times negative 6 is 108. Negative 18 plus negative 6 is negative 24. That's going to be our numbers. And again, calculator, divide by 1, 2, 3, like you can go through the whole list real fast to figure out, okay, where is it add to negative 24? So we pull that negative 24p apart into negative 18p and negative 6p. Same thing, it's equivalent. We can mess with it as long as we don't ruin the equivalency. And bring down the other parts so we have the whole expression. So 9p squared minus 18p minus 6p plus 12. We have our four terms. We can split it into the two binomials. And then we factor the first one and then factor the second one. So I have 9p squared minus 18p. Okay, if you need to, you can create the table, right? Whatever is going to help you be successful. I'm going to see like, hey, there's the 9. Okay, so 9 times 1 times p times p. And then I have 9 times negative 2 times p. So they have the 9 and the p in common. So I'm going to pull 9 times p out. And then what's left to get it back so that we still have 9p squared minus 18? Well, 9p times p gets me 9p squared. And then 9p times negative 2 is going to give me negative 18p. Okay, so those are equivalent. Remember, we're just getting it so that I can find the factors. What do I multiply, right? All right, let's go. Negative 6p plus 12. Okay, again, if you need to, you can do the factor trees and go look for it. Okay, this is your experience, so whatever you need, do it. You'll find that 6 is the greatest common factor. Okay, so we're going to have 6 times negative 2 times p, not times negative 2 times negative 1, 6 times 2, so we have that 6 in common. So I put 6 times, and then I'm going to have times negative 1p, and then times 2 to get 12. Okay, so look, I have p minus 2, but then I have negative p minus 2. Let's see if you remember. If they look the same, but the signs are opposite, that means, hey, I could pull a negative out, right? Because then that would be, if I pulled out negative 6 instead, negative 6 times p is negative 6p. Negative 6 times negative 2 is still positive 12. These are equivalent, so I can rewrite that 9p times p minus 2. The second one, I can rewrite it as minus 6 times p minus 2. It still tells me the same story, but now I have a common factor. Okay, so manipulate it to make it talk to you. Both of these are multiplied by p minus 2. So I'm going to pull that factor out. That's my greatest common factor. And then I look like, okay, what's left over? Well, I have to do p minus 2 times 9p. So I still have to multiply by 9p. And then p minus 2 times negative 6 would give me my second term. There we go. Awesome. We're not done yet, though, because I have to look for common factors if there's any lingering. So in my first parentheses, I have 1 and negative 2. So no, nothing's the same there. I have 9 and negative 6. Wait. Both of those can be divided by 3. So I have to pull 3 to the front because it's a common factor. We always pull the common factors out. And then I just see what would be left. Well, 3 times 3p would equal 9p. 3 times, well, 6 divided by 3 is 2. So times negative 2. 3 times negative 2 is negative 6. That would be my final factorization. Multiply that all out. Boom, I get 9p squared minus 24p plus 12. Okay, so our goal is what's being multiplied to give me that. Make sure you've pulled out all the common factors. That's what factoring is. Pull out all the common factors, and there we go. One more. 6m squared plus 14m minus 12. First, we do our product sum, so we can split apart the middle. So 6 times negative 12 is negative 72. And then the middle term is our sum, so 14. And again, we have to figure out, okay, what am I multiplying? That's going to give me negative 72. And you could do the whole list, right? Negative 1, 72. Negative 2, what would that be? That'd be 3, 36, right? Until it adds to positive 14. Like I know, hey, that's too big. That's 34, right? And you keep going. Use your calculator to help you. And eventually you're going to get to like, hey, if I see negative 4 times 18, that's negative 72. Negative 4 plus 18 is going to give me the 14. So I'm going to use negative 4 and 18 to split apart 14m, right? So this is going to be negative 4m plus 18m. Remember, equivalent still, just in a different form. And rewrite the other parts that I didn't touch. So 6m squared minus 4m plus 18m minus 12 is the same as that top expression. Now I have my 4 terms, binomials, a group first 2, group the last 2, and we factor. So 6m squared minus 4m. So I'm looking, okay, biggest common factor of 4 and 6 is 2. So this is going to be 2 times 3 times m times m. Negative 4m is going to be 2 times negative 2 times m. And I look for what's the same. They both have a 2. They both have an m. So I'm going to pull 2m out times. Okay, how do I still keep it 6m squared minus 4m? Well, 2m times 3m gets me 6m squared. 2m times negative 2 gets me back to the negative 4m. Okay, so they're equivalent. I just factored it. Look at the second one. 18m minus 12. If you need to, make your list. Use the calculator to help you out with this part, right? Okay, and we're going to see, hey, they both have 2, they both have 3, they both have 6. 6 is the biggest one, so that's what we're going to use. So 6 times 3 times m is 18m. 6 times negative 2 is negative 12. Okay, they have a 6, so I'm going to do plus 6. And then How do I multiply so it's still 18m minus 2? Well, minus 12. 6 times 3m gets me 18m. 6 times negative 2 is negative 12. So I still have equivalency. And now I look, okay, I have my two things, but I'm still adding. I'm not at the multiplication yet, which is my ultimate goal. But I look and I'm like, hey, they're both multiplied by 3m minus 2. Sweet. We pull that out, 3m minus 2. And then we ask ourselves, well, what's left over to multiply? I have 3m minus 2 times 2m, so I have to multiply by 2m. And I have 3m minus 2 times positive 6. I have to do times 6. There we go. And now we look, are there any remaining common factors? So I look at 3 and negative 2. Nope, their common factor is 1. And then I look at 2 and 6. Ooh, 2 and 6. This is 2 times 1. This is 2 times 3. So we have to pull the 2 out. So 2. The first one I didn't touch, so that stays 3m minus 2. This one, I'm going to have 1m plus 3, because 2 times m is 2m. 2 times 3 is 6. There's my final factored form. Okay, look for the patterns. Look what's happening. We're manipulating it, but maintaining equivalency. Okay, we manipulate it so that we can factor the binomials, and then we can factor the new terms so that we can get to a multiplication problem.